Okay, so here Lenny made a cube in technology class. Each edge measured 1.5 centimeters. What is the volume of the cube? Well, with the cube, remember that the edge is just referring to the length of each side, right? If we sketch our cube here, right, this is our cube. The edge is referring to this length right here, and this length right here, and this length right here. And in a cube, those are all the same, right? That's the definition of a cube. In contrast, they might talk about a vertex right here, right, the points where edges meet, or a face which is surrounded by the edges. So, so what are we doing here? Well, remember that to find the volume, we just multiply these dimensions. So each dimension is 1.5 centimeters, right? And that means we literally, to find the volume of a 1.5 of a cube with edges of 1.5 centimeters, we find 1.5 cubed, right? And that's it. So here, right, we enter 1.5 raised to the third power. That's 3.375. And here, that's choice 2. Okay, in this problem right here, we are painting this toy box, and we're told that it's 3 feet long. So we sketch this out, by 1.5 feet wide, by 2 feet high. Okay, so maybe a rough sketch would be like this. And we're just going to label our sides. This is 2 right here. And surface area is just the sum of the areas of all the faces. So this is a face right here. And that's just 2 by 3, or 6. So that's one face. And the opposite 6 as well. The opposite faces are always equal. Now the top face over here, what's that? Well, it's 1.5 by 3, which is 4.5, right? And the bottom is also 4.5. Then we keep going, right? Our front piece over here, this is 1.5 by 2, right? 1.5 by 2 is just 3, right? And the rear face over here is also 3. So we have 3 and 3 is 6, 6 and 6 is 12, 4.5 and 4.5 is 9. We sum those up. 9 and 12 is 21, plus 6 is 27 square feet, right? Which is choice 4. We keep going here. Here we're given 2 tanks, right? Joe's larger tank is completely filled with water. He takes the water and fills it completely into the small tank. Determine how many cubic inches of water will remain in the larger tank. So, right, all the water is being poured from the larger into the smaller. So if we do that perfectly, if you think about what's happening, right? That means whatever the volume is of the smaller tank, we'll be subtracting it from the larger tank. So first we have the larger tank, which has a volume of 12 by 30 by 16, and we're subtracting the 6 by 12 by 9 tank from that, and that will be the volume left in the larger tank. So we can plug that in quickly, right? Parentheses 12 times 30 times 16, close parentheses, minus parentheses 6 times 12 times 9, close parentheses, and enter. And our answer is 5,112 cubic inches. That is the amount that will remain. Let's keep going here. In this one, we're told that a soup can is in the shape of a cylinder. The can has a volume, so the volume of the can equals 342 cubic centimeters, or centimeters to the third power, and the diameter equals 6. Express the height of the can in terms of pi. So, right, the volume of a can is going to be equal to the area of a circle, pi r squared h, right? Area of a circle, pi r squared, times the height. And we're getting 342 centimeters. So we know that pi r squared, well, if the diameter is 6, then the radius equals 3. So the radius squared is just 9, times the height. It's going to get us 342 centimeters cubed. And I'll leave the units out of this instead of including them on both sides. So anyway, we have 9 pi h equals 342. So there, 9 pi is just a number. So you can think of this as 9 times pi times h equals 342. So what does h equal? Well, think about the logic in most algebra problems like this. If I said, what is 9x when 9x equals 27? What is the value of x? Well, you could divide both sides by 9 to find out that x should equal 3. And you could do that because x is being multiplied by this number. Same idea here, h is being multiplied by this number. So we just divide both sides by 9 pi. Well, it's not as friendly looking, but it works. So h equals 342, right, divided by 9 pi. But 342, 3 plus 4 plus 2 is 9. So we know that 9 goes into 342, so we can reduce. 342 divided by 9 is 38. So it's 38 over pi, and that's our height in terms of pi. And if we need to include units, that would be centimeters, so you just write centimeters here. Determine the maximum number of soup cans that can be stacked on their base between two shelves. The distance between the shelves is exactly 36 centimeters. Explain your answer. Okay, so let's clear this off. Alright, so I guess the assumption is if we have a shelf, right, and then another shelf here, these will be our shelves, and we know that the distance between them is 36 centimeters, we need to find out how many cans fit in this distance without going over. So, right, how many cans can we stack? So if this is our height, right, 38 over pi, then we can say, well, what's 36 divided by 38 over pi? That will tell you how many times the height of the can fits evenly into the shelf. In other words, how many times you can stack them. This is kind of easy to do on a calculator. You can go 36 divided by, enter your parentheses. Now you enter this fraction, 38 divided by pi, or over pi. And there's a pi button. Hit second exponent for pi. You'll see that symbol. Press enter. You get about 2.976, let's say. So it's about 2.976. So think about what this means. This means that 2 full cans will fit. And the reason we're rounding down, right, is because this division process is saying, oh, okay, if you want to equal 36 inches, you take 1 can, you take a second can, and you take a, let me fix that. Then you take a first can and a second can, 1, 2, and then almost an entire another can, right, but not a full can, you don't need a full can, to reach the top there. So a little bit under 3 cans will equal the height of the shelf, but these kind of problems assume that you can't cut a can apart or include this fraction of a can. So 2 full cans will fit, and then most of a third, but not entirely. So we just say 2. And again, if you got like 3.5 or 3, then you would round it down to 3. But anytime you get any fractional part here, and you can't cut the can apart, you round down. Okay, let's keep going here. We have some more questions to look at. Okay, go to the next set. Okay, well, here they want us to find the volume and surface area of this prism. So let's find the volume first. Volume equals 10 times 2 times 4. That's just the dimensions being multiplied. So that's 10 times 2, which is 20, times 4, which is 80, and you want to add your units here, cubic centimeters. The TSA, the total surface area, that's just going to be the area of all the faces added up. This face on the front is what? Well, it's 10 by 4, or 40. So that's 40. And then the same on the back there, it's 40. On top here, this is 10 by 2, or 20, right? The same on the bottom. And then we have 2 more to go. Here, this is 4 by 2, or 8, and this is also 8. So we add these up, right? We have 2 8s, 16, plus 40, 56, right? Plus 80 is 136. So 136 square centimeters. And all I did there was add those up, right? 40 plus 40 is 80. 120, 136 centimeters squared. Moving on here, a cylinder has a diameter of 10 inches and a height of 2.3 inches. What's the volume? So the volume is equal to the area of a circle, pi r squared, times the height. So we just plug this in. Pi r squared, well, r is half the diameter, or 5, and 5 squared is 25, times the height, 2.3. Okay, so on the calculator, we enter the pi button, second pi over here, times 25 times 2.3. Oops. Fix that. Times 2.3. And we get 180.64157. or here, choice 3, 180.6. In the next problem, we're told that we have this prism. What is the surface area? Okay, well, we break it down piece by piece. Right here, we have this face and this opposite face over here are equal. Those are both 3 by 7.5. So we have 3 times 7.5 would be one face, but since there are two of them, we double that. Okay, I'm going to leave that here. Next, we add in the next faces we're looking at. Let's look at this top face here. Right, this top face and this bottom one. Those are both what? 2.2 by 3. So 2.2 times 3, but there are two of them, so we double that. And lastly, we add in the front face here. Right, this front face. The colors are getting blended here. And the one all the way in the back, those are also equal. Those are 2.2 by 7.5, right? So here we have 2.2 times 7.5, but again, there are two of them. So we double that. And now it's just a matter of entering all of this in, right? We have parentheses, we have 2 times 3 times 7.5. I just changed the order of the first group. 0.5, close parentheses, plus open parentheses, 2.2 times 3 times 2, close parentheses. So far we have 58.2 plus what? 2.2 times 7.5 times 2. Then we close parentheses. Enter. We have 91.2 centimeters, or choice 4. Okay, we're getting there. The volume of a cylindrical can is 32 pi. So the volume is 32 pi cubic inches. If the height is 2, what is the radius? Well, this is just a basic algebra problem because volume of a cylinder is pi r squared, a circle, times the height. And here they're saying that the height is 2, okay? And they want us to find the value of r. But this volume is equal to 32 pi. So we solve for r. We kind of rearrange this on the right-hand side. Instead of pi r squared 2, we have 2 times pi times r squared. Because 2 pi is a number and r squareds are a variable, I like to keep those separate. And that equals 32 pi. Alright, so when you're trying to solve for r squared, we can just divide both sides by 2 pi. And look how nice this becomes. Here these cancel out. Pi divided by pi is 1. 32 over 2 is 16. And this means r squared is 16. And I'll write that up here. But if r squared is 16, take the square root of both sides, and r equals 4, the square root of 16. So we have choice 4. Alright, 2 more problems to go. Alright, the length and width of the base of a rectangular prism are 5.5 centimeters. Length is 5.5 centimeters, and width is 3 centimeters. The height is 6.75 centimeters. Find the exact value of the surface area of the prism. Okay, well, with all these surface area problems, you just take all the combinations of the dimensions that gives and multiply them, because those give you the areas of the faces, and then double them. So this is the way I'll do it. I'll take length by width, right, and then double it. There are two faces that are length by width. Then length by height, and then double it because there are two faces that are length by height. And then the last combination is width by height, right? And then we double that. And that's it. So now we just plug these numbers in. So let's take the calculator out here. Okay. So length by width, that's 5.5 times 3 times 2, 33, plus, I'll put parentheses here, length by height, 5.5 times 6.75 times 2, okay, close parentheses, and then plus 2 times the width, 3, times the height, 6.75. Close parentheses, enter. Okay, we have 147 0.75 square centimeters. Don't forget those units there. Just double check. Oops. Double check. Yep, it's 147.75. And the last problem in the set. Mike buys his ice cream packed in a rectangular prism-shaped carton, while Carol buys hers in a cylindrical-shaped carton. The dimensions of the prism are 5 by 3.5 by 7, and the cylinder has a diameter of 5 and a height of 7. So, which container holds more? And then, how much larger is one than the other? Okay, well, let's sketch these out. A rectangular prism, right, something like this, is holding ice cream, and we're told that it's 5 by 3.5 by 7. So maybe 7 is the height, we'll say 3.5 is the length, and we'll say that 5 is the width. So the volume would just be these three things multiplied. 5 times 3.5 times 7, right? So let's just figure out what that is real quick. 5 times 3.5 times 7 is 122.5. So we have our volume. That's how many cubic inches this holds. The cylinder, however, will be different, I think, because here the diameter is 5. Okay, so we have the cylinder, and the height's the same. Okay, so diameter is 5 here. Let's say d equals 5, and the height is 7. However, the volume now is pi r squared h, because it's the area of a circle, pi r squared, times the height. So if the diameter is 5, that means the radius equals 2.5, and the radius squared equals 6.25, and the radius squared times the height equals what? Well, we have 6.25 times 7. It's 43.75, right? But we're multiplying that by pi. So times the pi, or second exponent button, 137.44. So the volume equals 137.44 cubic inches. And they now want us to say, well, how much more ice cream is that than the rectangular prism holds? So now we just press minus, and then we subtract the 122.5. And they want us to the nearest tenth. So it's 14.94, or therefore 14.9 cubic inches. And that's it. All right, hope that helped.